Let's look at rotary compressors. A rotary compressor uses a rolling piston with a cylindrical housing to compress refrigerant vapor against a reciprocating vane. The spring above the vane holds it in contact with the rolling piston at all times, providing a vapor-tight seal between the high and low pressure zones within the compressor. There is only one valve, the discharge valve. It takes 2 full rotations of the shaft to draw in and compress a volume of refrigerant vapor. Notice how compression and suction occur simultaneously on opposite sides of the rolling piston. For example, starting at top dead center, as the eccentric shaft rotates the rolling piston past the suction port begins to open, forming a space between the vane, the rolling piston, and the housing. With continued rotation, the volume of this space increases, reducing the pressure below the low side pressure of the cycle. Refrigerant vapor is drawn in through the suction port for a full rotation until the compression volume is filled with suction vapor at low pressure. In the next rotation, the rolling piston blocks the suction port. Low pressure vapor is compressed in the decreasing space between the rolling piston, housing, vane, and discharge valve on the other side of the piston. Initially, the discharge valve is closed, trapping the low pressure vapor. Continued rotation of the rolling piston along the inside of the housing reduces the volume of the vapor, compresses it against the vane, and raises its pressure. When vapor pressure exceeds the high side pressure, it pushes the discharge valve open. Discharge continues until the rolling piston completes the full revolution and has expelled most of the high pressure vapor. The discharge valve closes when the rolling piston reaches top dead center. Then the cycle is ready to begin again. This is the mechanical positive displacement vapor compression cycle using a rotary compressor. Please take a moment to complete the following learning activity. To continue, make your selection. Let's look at screw compressors. A screw compressor, viewed from the end, has 2 helical or screw-shaped rotors. One is a male thread, while the other is female. Their shapes allow them to compress refrigerant vapor as the threads of the 2 screws mesh together. The compressor motor drives the male rotor, which in turn drives the female rotor. This design has 4 lobes on the male rotor and 6 on the female. Therefore, the male rotor rotates faster than the female. As viewed from the top, refrigerant vapor enters the suction area of the screw compressor and is trapped between the 2 lobes of the rotors and the compressor cylinder wall. Many designs use an oil injection system to seal the clearance between the rotors and the cylinder. The screw threads form the boundary separating several compression chambers, which move down through the compressor at the same time. To simplify, we're showing only one such chamber. As the vapor moves along in the compressor, the compression chamber becomes somewhat reduced in volume. The compression space gets progressively smaller until the gas exits at the compressor discharge in its fully compressed state. This side view shows refrigerant vapor flow through the screw compressor from its suction to its discharge. Compression is nearly continuous, and the screw compressor operates smoothly. This is the mechanical positive displacement vapor compression cycle using a screw compressor. Please take a moment to complete the following learning activity. To continue, make your selection.
Centrifugal pumps are the most preferred pumping devices in the hydraulic world. In this video, we will have a conceptual overview of working of centrifugal pumps. At the heart of the system lies the impeller. It has got a series of curved vanes fitted inside shroud plates. The impeller is always immersed in water. When the impeller is made to rotate, it makes the fluid surrounding it also rotate. This imparts centrifugal force to water particles, and the water moves radially out. Since rotational mechanical energy is transferred to the fluid, at discharge sides of impeller, both pressure and kinetic energy of water will rise. At suction side, water is getting displaced, so a negative pressure will be induced at I. Such low pressure helps in sucking fresh water stream into the system again, and this process continues. This is the reason why priming is important for centrifugal pumps. If no water is present initially, the negative pressure developed by rotating air at eye of impeller will be negligibly small to suck fresh stream of water. Impeller is fitted inside a casing, so the water moving out will be collected inside it and will move in the same direction of rotation of impeller to the discharge nozzle. Here you can note one specialty of casing. It has got increasing area along the flow direction. Such increasing area will help in accommodating newly added water stream and will also help in reducing exit flow velocity. Reduction in flow velocity will result in increase in static pressure, which is required to overcome resistance of pumping system. Here you can see more details of vanes inside impeller. They are backward curved vanes with state-of-the-art eye configuration. This vane is extracted from a Kirloskar pump model. If pressure at suction side of impeller goes below vapor pressure of water, a dangerous phenomenon could happen. Water will start to boil, forming vapor bubbles and spoil impeller materials over time. This phenomenon is known as cavitation. More the suction head, lesser should be the pressure at suction side to lift water. This fact puts a limit to maximum suction head a pump can have. Careful pump selection is required to avoid problem of cavitation. Current impeller type is enclosed. Semi-open and open impellers are also in use depending upon application. If the working fluid is cloggy in nature, it is preferred to use open kind of impeller, but they are slightly less efficient. Mechanical design of centrifugal pump is always challenging. A shaft is used to connect between the impeller and motor. Since water pressure inside casing is huge, a proper sealing arrangement is imperative in arresting water leakage through shaft casing clearance. Mechanical seal or stuffing box-based mechanism is used for this purpose. Impeller is mounted on bearings, but at suction side of impeller, it is not advisable to fit a bearing since it will block the flow. So bearings have to be fitted at the other end. This means impeller is mounted like a cantilever. For high flow rate pumps, a bearing housing with cooling oil is necessary for improving life of bearings. We thank Kirloskar Brothers for their technical support and creation of this video.